There it is, folks. Yes, it is. And what this krypton ray does, it takes electricity from the sky and puts it into that plate. There, you see. And you always want a body standing in between the plates, so we got two inductors. We'll measure that later on. Then we got the other plate. Now, the positioning of these plates then, at the end of everything, last year we used 2 wires to get everything to where it was going. This year we used 1 wire. We use the ground. And then we arc that to ground. Let's see. By doing that, I can't see anything here. See if we can get a shot of that then. There it is. There's the arc to ground through the arc bars. And by doing that, when you stand in between there, seem to be losing visual on that. There it is. Yeah, the camera's got to be right in between them bars for that to be able to see. Yeah, by doing that then, you're interposing the body between an electrical arc and the sky. And then you can go from there on. You're thinking of it. Well, I think that's the way to go, and this is for the year 2017. Here we're looking at a 4-inch neon discharge to an aluminum plate area from the top component of the alternator resonant system. It's only delivering 100 milliamps times 7, about 700 volts. Bottom one about 600. Bottom one we don't include because this is a 1-wire demonstration. We're only using 1 wire from the process. The 1 wire goes up there also to the top krypton bulb, which is the normal method that we use to produce the high frequency electric field, which we call a multiple wave oscillator effect, because it does not broadcast a frequency, it broadcasts a resonance. And here what we got then is we got that bulb, that 4-inch neon bulb, over a 12-pound induction coil, and it's the same kind of induction coil that we use for a power source on the system itself, 2 of them in series. And right now we're procuring about 5800 hertz. That's at a 50 cycle, 50 microsecond per division on the frequency sweep, 1/2 volt on the voltage. So that thing's only picking up 1/2 volt from that bulb. We calculated at 170 microseconds cycle time, 3 cycles across that screen apparently. Then that would give us a cycle time of 580 hertz, 5880 hertz, near 6000 hertz. We've got this signature before from these kind of coils. Okay, now what we're trying to do then is get a shot of this simultaneously. We're going to disconnect the polar surface area connection. Note the difference in the radio waves emitted. We'll remove the source of electrons. Now when we did this enabled both bulbs to start working. But here we want to investigate this signal then. That was at 0.2 volts per division, or no, 0.5 volts per division. Turn that up. There's 1 volt, 2 volts. There's full top and 5 volts per division. So now we're getting there's a 2 volts per division. Uh, 2 volts per division, 50 microseconds per division from that coil there, having a much weaker discharge above it. And now then we have the krypton discharge being enabled. Okay, this is all connected by an arc gap system in between the ground plates and the process. So we've looked at this frequency then. Next we want to look at the frequency derived from 8 of these mega cable spiral stacks of 50 feet put together and wired in a bifilar fashion to create a higher voltage between the layers. Jumps 2 layers generally more often than it does 1. We could make it greater than that, but for now we're just looking at the signatures. Okay, I think that's hooked up to the scope. So we'll change the probe leads. At 2 microseconds per division. Okay, we got our signal there at 2 microseconds per division. And what was it? 521.5, half a volt. Ain't seeing nothing. Oh, there's our new frequency at half a volt. And well, that can't be right, is it? Yeah, that's right. That's 250,000 hertz. Okay. We've done got our 250,000 hertz signal from over there. And we're going to eliminate our neon bulb thing here. Might be interfering with stuff. And that decreased the signal slightly. Not much to see there, is there? Okay, finally we need to get to the toroid. That's being produced by single krypton discharge. And there's our toroid. I'm going to move the leads to the toroid. Takes amazingly long time to do clip jobs. Well, I should finish this video out then. You get a completely different frequency from that. That's at the same settings. 2 microseconds and half a volt. So to finish out here, we'll try to go